Today's topic is neuronal communication. I remind you, yesterday we studied about the excitation, mainly excitation. Excitation means when we stimulate the excitable cell. What is excitable cell? This is very important to understand. What is the difference between excitable? I don't say you, anyone, okay? This is not my habit to say you. It's not good. So what is the difference between the excitable cell and non-excitable? The old definition and general definition is, if you stimulate a cell and cell gives response. Like if I do like this, oh, I feel pain. It means this is. Did you get it?
Yes.
Precisely. If you stimulate electrically, this is the correct definition. Very, very specific. If you stimulate electrically and you get some response, if you stimulate your muscle will contract, right? But if you stimulate bone, it will not contract. So it means if you stimulate a cell or tissue, and that cell or tissue gives a response, contraction or conduction or something, this is excitable. Is it clear? And if you stimulate electrically and there is no response, means the cell or tissue is non-excitable. Students, is it clear? So what is the difference between excitable? Now this topic relates to excitable because we are studying neuroscience. It is the study of excitable tissue. So nerve cell, muscle cell, eyes, ear, senses, all those are excitable cells. But this was the old definition. I tell you one thing very interesting. The recent definition is a bit different. You will not find in the books, okay? But just keep in your mind and don't make it final, okay? But this is most modern. Excitable cells are those that contain ion channels. Excitable cells are those that contain a particular ion channel like voltage gated or ligand gated. There are mechanical channel, mechanosensitive, there are a variety of channels. So it means blood cells, the sex cells, the bone cells, all have the ion channels. But some of the channels, if you stimulate, they will not give response. Channels have different types. They all are not voltage gated. So the excitability is concerned with voltage gated channels. That's it. Is it clear or not?
Yes.
Excitability, the life activities that we do, those are done with the change in the voltage. Voltage means when we think something, voltage changes. Voltage changes means I am going to the cell. This brings voltage changes. When sodium go from outside to in, voltage change. What is voltage change? Voltage change means change of the ions between the extracellular and intracellular fluids. Change in the ions, number of ions in the extracellular and intracellular. The difference occurs. This creates voltage difference. And the normal voltage usually is minus 70, 80, minus 90. That is millivolts. Did you get it? So these voltage gated channels, the new definition is excitable cell, relates to voltage gated channels. So anywhere voltage gated channel, if the cell has that is excitable. And that does not have, like the sperm is excitable. Before that you said brain, muscle, these are excitable. All of them are, no. The modern now you have to keep this in your mind. Don't change the definition. In books you will not find it. Keep it, but keep this in your mind. That sperm is also excitable. Your pituitary gland is also excitable. It's an endocrine gland. You will be thinking it's not. No. If you stimulate, people are doing huge work on the electrophysiology of pituitary gland. Okay? They stimulate, secretions occur. The story is becoming very different. I don't like to confuse you, okay? These things are related to research at the cellular and molecular level. So I think you got it. So now we come back. Excitable cells are those, if we electrically stimulate, they give response. Okay? the journal left. If they do not give a response, they are not accepted. Okay. Now we come back to this lecture, and because we studied last time what is excitation, what is excitation means action potential. Excitation means impulse. Excitation means the formation or development of the impulse. Impulse means message. Impulse means what you say, risala. Message. I give you a message, you convey some other, this is message. But you convey, the leader conveys this message to everyone, this is conduction. This is? But the message I made that I will give assignments, these will be taught, this is message. This is only, it did not move. When I give to the leader sends everywhere, this is the propagation of the message. So one thing is message, and the other thing is propagation or conduction. Yes. One thing is message, development of message at certain makan, one place. Now this message goes from one place to other, because the purpose of the message is to inform others, to inform whole body. So this message or impulse will travel everywhere. This traveling is conduction. So impulse development, impulse conduction. We studied yesterday what is impulse, what is action potential, what is excitation, it's the same thing. And its conduction means after the formation of action potential, another action potential, they are summated. And I move my hand. I cannot move my hand just by one action potential. It needs maybe 1,000. So when 1,000 action potential occur, they summate it. And summation occurs by makan and by zaman. You understand? I mean, this place, that place, all are collectively. They collect. And the other is, in the first second, in the second second, in the third second, makan and zaman, according to time, zaman. So according to zaman first second, zaman second second, zaman third second, all occur. This summation is temporal. What do we say? By time, by zaman. And what is the makan? Spatial, space. Space means makan. So spatial summation, and you will study, don't worry, it's coming. So the excitation, and the other thing we studied is axonal transport. You remember axonal transport? So please you remember what you studied. This is very important. If you do not remember you studied, you have a clear concept what we studied and what was it and what is the significance of that and what is its relationship with the diseases. And if we do not know that, there is no need of study. If we do not have a concept of certain topic and what is the application of that topic, what is the significance in medicine because you are medical students, which disease, I think just the idea, you will study more in pathology in fourth year, fifth year, final, but at least you must know that what is this and what is its application in medical disorders, okay? And you can arise question, so we studied excitation, conduction, myelination, unmyelination, role of myelination, and then how the substances flow from the axon to the neuron body, from neuron body to axon, how the substances are normal physiological and toxins and viral, how disease occurs through axonal transportation, all those. So what is the significance of retrograde and anterograde axonal transport? So this has much importance in medicine, okay, in normal physiology and also in pathophysiology. So this was what we studied, and the next is communication. So today we will study, the two cells, when they combine with each other, they come like this. I think your marker is okay now today. Good. And I also brought here to open it. Yes. Right. See, if this is a cell, I can write here, okay? If this is a cell, this is one cell, okay? I'm not making the full cell. It ends here. There is another cell. You say presynaptic cell and post. Why you say presynaptic? Because this is before the synapse. This is synapse. Synapse is the area, empty area. Empty plus this membrane plus this membrane. This whole is synapse. Synapse is the connecting place or makan between two cells. And it's a functional unit that performs a function. So two cells come nearby, close, and the connecting parts means the last part of first cell, the first part of the second cell, they collectively are called as synapse. Is it clear? Yes. What is synapse? So you can say synaptic connection, synaptic communication will occur, and synaptic transmission means the conveyance, going of message from one cell to other. This is the purpose. So going of a message from one cell to other. Okay, I will read it. I always read because when you go home, who knows which word you did not understand? It's easy for me showing slide and showing no. Sometimes there are some difficult words, and the other thing is if you find any word, any sentence, you should arise question, children. Okay? This is otherwise I can just explain and go ahead in 10 minutes lecture is finished. No. You must tell me. So what are synapses and the mechanism of synaptic transmission or neurotransmission? Who performs neurotransmitters? What are neurotransmitters? I mean the messengers that produce risala, neurotransmitter, brain substances that are related to messages, transmitters. Neurotransmitter means they are related to neurological disorders, neurological processes. So they are released and they recognize they check the type of the channel. Inotropic means the voltage gated and ligand gated. You know, we have discussed voltage gated. You understand what is voltage gated? Do you understand when I say? You understand my English? Maafi mushkil?
Yeah.
You should say me to. Actually, I speak a little fast because we have huge material and we have to cover. But I think it's easy. If it remains difficult, you must tell me. I can repeat, and you can come later, and we can discuss in any time or my office okay. And you should say to your leader, and leader can tell you, right? Okay, children. Inotropic means when ions move from out to in or in to out. Ion moves because of voltage difference. Ion move because of when the ligand come and attach. Is it clear or not? So voltage gated and ligand gated. Ligand gated means chemically gated. Both, the resultant is ion movement. The result is, so it means the inotropic receptors. The receptors are inotropic. Okay. There are other receptors. They use second messenger, cyclic AMP. They are related to the signaling. For example, inside the cell, the cyclic AMP comes and then the message goes, not only by the ion movement. So those are metabotropic receptors. Okay, students, is it clear?
Yes.
Because we are not going in details and we're just explaining what are inotropic and metabotropic. Though we should go in detail, maybe we need one extra class, actually. But in simple, it's, yes. Again, okay, yes. Inotropic means, inotropic receptors, any receptor that relate to movement flow of ions. Flow of ions. Now flow of ions occurs because of voltage difference. So voltage gated receptors are ion. And ion movement occurs also because when some chemical binds, chemical receptors, ligand gated, chemical gated. So voltage gated and chemical gated, all those channels are receptors, same thing. They are inotropic receptors. Okay, is it clear? Inotropic receptors? Inotropic receptor means ion goes whether due to the change in the voltage or due to the change in the voltage because of the combination of chemicals. But the resultant is the change of voltage. Whether it directly occurs because of voltage or by combination of chemical, but the result is voltage change. Voltage change means ion going in or out, voltage changes. And you know what is voltage? When you separate the ions by a membrane or any layer, that does not allow the ions to move. All the ions strike to go hither and thither, they cannot go. Some of them go, but others do not. So they create a difference in the two departments, two compartments, and voltage is created. In both sides is current. Interesting. Sodium is current, positive current. Chloride is current, negative current. Current is separated. Inside of the cell is current. Outside of the cell is current. When current in two compartments is separated, the difference of these two current areas make another difference that is called as voltage difference. Is that clear? Now the difference between current and voltage, you got it? Current is simply flow of electrons, electricity, current. But change of current makes difference in current, and we do not say difference current, we say voltage difference. And current we specify with amperes, amperes. Voltage we write with volts or millivolts. Current, amperes, and voltage, volts or millivolts. Is that clear? So voltage difference occurs whether channel is the voltage gated or ligand gated. And the receptors will be called as ionotropic. Tropic means affected due to ion movement. Regulated due to ion. But if the ions are not regulated just by the ion movement, but some other messenger is needed, cyclic AMP or any, I don't go in other details, it will confuse you. So if we are involving signaling substances of cyclic AMP, it comes from inside the cell, it makes a relationship with the channels or receptors, and now the signaling means messaging. Signaling means I give you a message, you give to you, this is a signaling. Giving message to others is signal. Now you can tell others, oh, do this, and all together do some activity. So you can say signaling or messaging. Children, it's clear. Describe the generation of cytatory. This is easy. We will study. These are the purposes, and because these are interactive lectures, we must have. So spatial and temporal. I will tell you. I just talked a little bit. Something else. What is describe all the inhibitory. These are the samples. I think the synapse and active potential and temporal summation and neurotransmitters and neuronal integration. These are the topics. Now, number one, synapse. You know what is synapse? Any confusion? So synapse, the first cell is called as presynaptic, and the second is postsynaptic. Who used these terms? One Baba physiology, and his name is Sherrington. What's his name? 1800 something. He was the founder of physiology, and he used these terms. He was the Nobel Prize, I think, in the start of this 1901 or 2. Very poignant, the leisure. So one of his students was John Eccles, my teacher. So he also got Nobel Prize. So the Professor Sherrington used. Who used? This is not included in your course. You just study internet. You can. Professor Sherrington used presynaptic, postsynaptic, and in between is the cleft. You know, this empty place is cleft or gutter. So in this, chemical substances come and combine upon the other membrane. And when message comes from one cell to other, it is the interaction of two cells. This was discovered by a student of Professor Sherrington, and his name was Professor Eccles, John Eccles. He was basically from Australia, and he was a chairman department of physiology in one New York University for a long time, my teacher, and he discovered the cells are connected by current. No one knew before it. Cells are connected by current. At that time, people did not believe it. It was 1890s and later 1900, and he got Nobel Prize 1968 something with Eccles, Hodgkin, Huxley, big people who discovered the voltage. I mean, very big group. So you got it, okay? What is synapse? Now you will remember. See, a junction that mediates the information from one cell to another. Okay? What is presynaptic or postsynaptic type of synapses? Okay, when axon combines with the dendrite, exodendritic, when the exosomatic, what is somatic? You know, okay. Exoaxonic, clear? Okay, and dendrodendronic, dendrosomatic, it's easy. This page is easy. Now we will go quickly. When there is something related to concept, we should explain. When there are simple things, we should be a little careful. See, very interesting thing. I told you Professor Sherrington used presynaptic, postsynaptic. His student, Professor John Eccles, he died. I was in Toronto. I was doing postdoc after my PhD in the postdoc. 95, I think you was not born. Huh? In 95, he died, I think 96 or 97, forgot. And Professor John Eccles. And he was at that time in Sweden or somewhere. Okay, anyways, Professor Eccles did not believe chemical synapses. He was Nobel laureate. He said all synapses are electrical. He thought electrical current combines. Later people discovered no. Beside electrical, sometimes synapses are combined by acetylcholine, adrenaline. Message does not go only by current, it can go also by current. But later when John Eccles believed, yes, he said right. But initially he said no. Huh? So, I mean, this is science. If someone is a big guy, still, one of his students, I told you in first year, Sanatadiria, his student, Ito, discovered that it does not go hither or thither. This is the cerebellum, that posture, the glit posture, and he got Nobel Prize. And then John Eccles said, no, it's not possible. But later he came to conclusion, sometimes students are higher than their teacher. You know? Who knows? So I told you in first year, if you remember. So this is the same John Eccles. Saint John Eccles, he said only electrical science. What are the electrical science? Electrical means quickly jumping from one cell to other, no any chemical combination, no nothing, just by junction. You know, kubri, but don't jump, okay? Jump for kubri, don't do experiment. So kubri, there's no need of chemical, one side to other. So less common than they relate to gap junction, and they are important in brain, central nervous system. Okay, so and they're important in sleep. When you will study in your higher, if you become psychiatrist, neurologist, neuropsychiatrist, then you will study the role of electrical synapses, particularly from the sleep when you get up. So this is actually electrical, main involvement of electrical synapses. And then the mental attention. I'm sitting, but when I think mentally, what are synapses? I think this mental process needs electrical. If chemical mediation occurs, then it needs maybe hours and hours to think. So Allah Kareem made the electrical system. Quickly we think and we get it. But if it is chemical, then mental process may take 10 hours and then I say, what is that? Subhanallah. It's a Nama Kabir. Really? Subhanallah. We should say Alhamdulillah. Yeah, really. This is blessing. Are you getting? Yeah. Okay, good. We come to here. Emotions. What are emotions? I become happy. I become disappointed. These are emotions. And memory. Hafiza. You say Hafiza? Hafiza. We remember. So all this is like and ions and water homeostasis. Balance it. This page is simple. And now Professor Eccles did not believe initially. But later he came to know, okay, yes, I was wrong. Okay? So the specialized release and reception of the, acetylcholine. Acetylcholine comes from the brain and excites muscles. So one good example, there are two parts. So I told you, this is the, maybe this is a cell. Maybe this is a cell, and this is the axon. This is axon part, and this is maybe the soma. So axon ending, when axon ends, it makes like this, And one of this goes and, I'm talking about this, okay? And yes, axonal terminal of the precenter which contains synaptic vesicles. You know that. Yes. And they are broken down, acetylcholine comes out, it goes out from the membrane and sits upon the second membrane, postsynaptic membrane, and the receptors are there, acetylcholine combines with the receptors, and contraction occurs, twitch occurs, and when twitch is no more needed, it is destroyed by an enzyme, right? So neuromuscular junction you have studied. Did you study? Neuromuscular junction, right? It's easy, but you can study more if you forgot. So the receptor region on the dendrite or soma, this is postnap. Receptor is present here. The information comes from here and the receptors are here, right? So for example, if acetylcholine comes, it will combine here. Is it easy?
Yes, sir.
And the functional. Because my part is very initial lectures, so we have to talk about the basic concepts. But the other teachers will go in detail, even myself, when I will come back in 7th week, we will study sleep, coma, consciousness, shu'ur. We will be discussing much more, because you will study from other teachers, the motors, physiology and sensory physiology, then we will enjoy much. But at this time, the very basic concepts. We will not go hither and thither. Neurotransmission, simple. From the presynaptic to postsynaptic, transmission of message is neurotransmission. Neurotransmission occurs by the help of two types of transmitters. One is excitatory, one is inhibition. Yesterday I told you the concept of excitation and inhibition is very big. And the balance of excitation and inhibition equilibrium, it creates normal function or abnormal. If there is imbalance in excitation, for example, excitation is more, excitable disorders like the epilepsy may occur. If inhibition is more, depression and some psychiatric disorders may occur. So this is the balance of excitation and inhibition, but it is excitation and inhibition actually means neurotransmission. So transmission occurs and excitation occurs. Transmission occurs and inhibition occurs. Is it clear? So it means the amino acids transmitters are of two types. Excitatory, for example, acetylcholine, and inhibitory, like gamma aminotransferase. But sometimes some neurotransmitters serve. You understand, serve?
Yes.
They play a role. Both has excitatory and inhibitory. For example, acetylcholine in muscle, skeletal muscle is excitatory, but in herd it is inhibitory. So it depends where the substance is. Is that clear? It's coming. It's coming somewhere here. So the termination of this will affect synaptic delay. Synaptic delay means when substance vesicle is broken in the presynaptic cell and it comes out, it takes some time to come upon the postsynaptic membrane. I mean, it takes some time, some delay. It takes some time, right? For the release and coming and sitting upon the postsynaptic membrane. Are you getting my point? So this is not it is written. Postsynaptic means, as I taught, the neurotransmission cause excitation, some neurotransmitter. Others cause inhibition. If they cause excitation, they will produce excitatory potentials in the postsynaptic cell membrane. And if they are inhibitory, they will cause inhibitory potential where? Post, mashallah, you got it. I mean, presynaptic cell is for producing effects, messaging. And postsynaptic actually performs the results. So excitation or inhibition occurs in postsynaptic cell. I mean, this is the purpose. One cell is regulating the other cell. So the other cell will be performing the function. Is it clear or not? Okay, good. So if there is anything not clear, you can talk now or later, anytime.